this is a great example of what half of your test on Thursday looks like today. So you need to be good at this, half of it. Okay, if you were to do that, if you were to get half wrong, that would be poor. So they give you this f of x, and they are asking you 3 parts, an a, a b, and a c. Part A says, for what value of k, if any, is f continuous at x equals -3? Justify your answer. So we are trying to be continuous at -3. Which equation do I need to look at to be continuous at -3? The first one, does yours have a bar in between? That's a fraction, and so is this. I don't know why the fraction bar disappeared, but it did. Okay, there's a fraction. If I want to find continuity, to do continuity, you need a limit, you need a value. Which 2 equations are we going to use to find the limit at -3? First 2, right? And so we want to be continuous at -3. So to do that, I need to write the limit as x approaches 3, -3 from the left of f of x needs to be equal to the limit as x approaches -3 from the right of f of x. And eventually, I also need to make it equal to what? At -3, so f of -3. If I can show that all 3 of those things are equal, then I've proven continuity. Everybody understand what we're doing there? So we've got those 2 equations. Let's look at it. -3 from the left. All right, we're using this top equation. 2x squared plus 5x minus 3 over x squared plus 4x plus 3. And I'm trying to make that thing equal to the second one, kx plus 1/2. At what x value do I care about any of this information? At -3. -3 is the only place we care about. Other than -3, I don't care. Okay, so let's plug in -3. What happens on this first one if I plug in -3? It's 0 on bottom. Does it get you 0 on top? -3 squared is 9, 18. Oh no, we got 0 over 0. So what does that mean? We need to factor, we need to cancel, we need to plug back in. Okay, so let's try that. On bottom, that's an easy factor. It's x plus 3 and x plus 1. On top, it might be a little bit harder. If you're not good here, you know that there's probably going to be one of those 2 factors the same as on bottom. Okay, but if you need to factor on the side, please do that. I'm going to do borrow and payback real quick if you've forgotten how to do that. I'm going to take the 2 and borrow. I'm going to factor x plus 3, x plus 6 and x minus 1. I got to pay back, so I got to divide by 2. This is x plus 3. This one I can't reduce, so it's 2x minus 1. I take that 2 and put it back in front. If you've forgotten how to factor, that is a skill you need in my class. All right, so we factored it. What can I do now that I've factored? Cancel. My x plus 3's go away. Then I'm going to plug it back in. I take -3, I plug in. So I'm going to get 2 times -3 minus 1 over -3 plus 1. I get -7/2. Actually, +7/2 because they're both negative. Is that a little bit annoying? Sure. But do we understand the main idea? We factored, canceled, plug back in. A little bit more annoying than we want it to be. Deal with it. There's the left-hand side. Now we're going to do the right-hand side. Kx plus 1/2. What am I going to plug in? -3. So -3k plus 1/2. I'm going to solve. So I'm going to subtract 1/2. So now it's 7/2 minus 1/2. It's 6/2. So what is it really? 3 equals -3k. So my k is going to be equal to -1. That is the answer to this question. Okay. For what value of k if any, is it continuous? My answer is -1. I needed to show all of that work. This is a free response question. It's not just worth 1 point. You got to show all of that work. My justification, it's pretty much already stated there, but I always like to reword it again, okay? If k equals -1, then you might not have to necessarily rewrite it since we wrote it at the beginning, but I always like to. The limit as x approaches -3 from the left equals the limit as x approaches -3 from the right. And f of -3 are all equal to each other. Therefore, continuous. Kind of held your hand on the first one there, but I wanted to make sure we understood what was going on. Questions on how we're getting full credit there? We take each thing, set it equal to each other. We use the limit notation. If you don't write it in limit notation on your quiz, some of you just wrote the equations. Not going to count. Okay? Look at the answer, the grading sheet for this. This is how they would grade it on the AP exam. You would need to show the limit as x approaches -3 from the left. We did that. They got 7/2. You need to show the limit as x approaches -3 from the right. We did that. We got that thing right there. And then the justification, f is continuous if this is true, and that is true when k equals -1. So you got 1 point from the left, 1 point for showing it from the right, and then 1 point for a justification, which basically said all three things were equal to each other. Questions on the first one? Let's try the second one. What type of discontinuity does f have at x equals 0? So if we're looking at 0, talk with your neighbor. Come up with an answer for that one. Let's look. We're trying to decide what type of discontinuity does it have at 0. So if I want to know at 0, I want to know, all right, what's happening with my graph at 0? Which equation am I going to plug into to figure out what's happening at 0? Both of these two, because I want to know 0. There's two of them. Okay, so what we really want to do is kind of find the limit from both sides, just like we would normally do. I want to find what's happening on the left and the right. So the limit as x approaches 0 from the left of f of x, and the limit as x approaches 0 from the right of f of x. Cool? We're going to try to figure out what's happening. That's what I want to know. If they're equal, are they not? That's the information I'm looking for. Limit as x approaches 0 from the left of f of x. So I'm using this equation right here, this kx plus 1/2. Right here, I'm using this equation right here, which is 2 to the x all over 3 to the x minus 1. What am I going to do to find my limits? How am I going to find these limits here? Plug in 0. If I plug in 0 here, I get 1/2. If I plug in 0 over to the right, if I plug in 0, 2 to the 0, anything to the 0 power gets me what? That is a math fact you need to know. You're going to hear me say that all the time. That is one of them you need to know. Anything to the 0 power is 1. So this gets me 1 over 1 minus 1. It gets you 1 over 0. So what is 1 over 0 going to get you? DNE. So what kind of discontinuity is it if one side is 1/2 and the other one is DNE? It's a jump discontinuity. It's a jump discontinuity. If it's a whole, they would be approaching the same thing, and one of the values isn't going to be equal to each other. Okay? So like it would be, they both would be 2, but neither of them would be underlined. If it were like this. If it were like that, right? Does that make sense? If we're going to DNE, okay? If we get DNE here, it is a jump discontinuity. If you described it as a jump, I'm good with that. But if we're going to DNE, what does that mean? What value are we approaching if it's DNE? It's really going towards infinity. And if we're going towards infinity, what is happening on our graph if we're heading towards infinity? It's infinite. There's an infinity There's that infinity aspect to it too. I don't love this question. I have never seen them ask it before, but we can see it anyway. So we found the limit as x approaches 0 from the right, and then our answer. Okay, one side we're going towards infinity because the numerator approaches 1 while the denominator is 0. Great. We said D and E. We get full credit there. There is a discontinuity due to a vertical asymptote. I agree with that. We could also say jump. There was a jump happening at the same time. I think they would accept both answers there. Does that make sense with what we did? All right. I would say that we did that by writing the limits and then showing that they're not equal to each other. That to me is our justification. Sometimes justifications aren't always these big long sentences. I mean, you could just say the limits from both sides are not equal, therefore a jump discontinuity would be perfectly fine. And I think we've done that. Find all the horizontal asymptotes to the graph of f. Show the work that leads to this answer. Be careful here. Talk with your neighbor for a second. You're finding all the horizontal asymptotes of this graph. What does a horizontal asymptote mean? Horizontal asymptote is the exact same question as the limit as approaches infinity, kind of. Limit as x approaches infinity, or negative infinity. You got to look at both the left and the right-hand side. They're not always the same. Okay? Use that for a second. See what you can do. Talk with your neighbor. Come up with a good answer. We are trying to find horizontal asymptotes. The key to horizontal asymptotes, you're looking both ways, to negative infinity and positive infinity. Which equation are we going to use if we're finding the limit as x approaches negative infinity? The top one, because negative infinity would fall into that. And so down here, I'm going to find the limit as x approaches negative infinity of that equation right there. So 2x squared plus 5x minus 3 all over x squared plus 4x plus 3. If we're finding the limit as x approaches negative infinity, what are we going to look at here? The degrees. The degree on top is 2. The degree on bottom is 2. So what are we going to look at? Leading coefficients. What's my answer going to be? 2. That's my horizontal asymptote. Horizontal asymptote at y equals 2. Since it asked it as a horizontal asymptote, I could write y equals. If you don't write y equals, you'll probably be fine. Okay? Great. That only tells me half of the story. That only tells me what's happening on the left side when we go to negative infinity. We also want to find the limit as x approaches positive infinity. To find that one, which equation am I plugging into? The bottom one. The bottom one is 2 to the x all over 3 to the x minus 1. If I'm looking at infinity, I plug in infinity, it gets kind of weird. Where is it going to be bigger? On top or on bottom here? They're both sorry. We could talk about it being the same. I think it's easier to think about which one's bigger here because they're very similar in terms of they're both exponentials. But if I take 3 to a power, that's a whole lot bigger than 2 to a power. Okay, that's a significantly bigger number on bottom. Since this number on bottom is bigger, okay, you're taking that number on bottom bigger. If you wanted to make it 2/3, you don't know what it looks like, but 2/3 to a power is going to get closer and closer to 0 as you head that way because you're going to keep squaring the 3 on bottom. It is bigger on bottom, so if it's bigger on bottom, what are we going to approach? 0. Boom, those are my answers. Again, not a lot of work, not a lot of like writing out for a free response question. It was just showing your work. Here's what they wanted, okay? You wanted to show the limit as x approaches infinity. The answer is 0. Cool, we did it. We wrote that it was bigger on bottom. We don't have to write a whole lot more than that. Okay, the limit as x approaches negative infinity. That would get us 2 because we were looking at that. So we have horizontal asymptotes at y equals 0 and y equals 2. 1 point for the first one, 1 point for the second. Questions? Let's go to the back side. You've kind of seen everything now. Let's see what you can do without me holding your hand. So number 2, this is a question from 2006, the AP exam. A car travels on a straight track. During the time interval from 0 to 60 seconds, the velocity of the car is measured in feet per second. And acceleration A is measured in feet per second. Those are continuous functions. We don't really need acceleration on this question. We're not ready for that. Yep, it doesn't really affect you. The table shows you the values up above. So that's velocity and time. From 0 to 60, must there be a time when v of t equals -5? Justify your answer. Talk with your neighbor, come up with an answer, and write it out. You are looking for a value of -5 between two endpoints. Think about what we possibly learned that is trying to find you a value that is happening in the middle of all this information. See what you got. We're trying to decide, are you going to hit -5? Thumbs up if you think you're going to hit -5. Thumbs down if you don't think you're going to hit -5. Yeah, you should reach -5. Okay, that is a value we should have. Okay, if we are doing that, we need to talk about an interval. What interval, what x values did most of you use? I would use 0 and 60. Sometimes kids get crazy and they're like, oh, I'm going to use 35 and 50 because -5 falls between those two numbers. That's fine, but so do 0 and 60. So you could pick whatever numbers you want here, but I'm going to pick those. And so let's write our justification. Must there be a time? Yes. There must be a time where v of t is equal to -5. I always like to kind of rewrite what they say because it's going to allow me not to screw this up. But yes, there must be a time where v of t equals -5. Because, Ella, what did you say? What do I need to state in here? No, just tell me something. Because the function, and let's be a little more specific with the function. Let's say because v of t is continuous, but yes, you're correct. Because v of t is continuous, call it by name. Okay, that's something you're going to notice a lot here on free response questions. You need to state what the function is. You can't just say the function or it or the graph. If you did, cross it out. Write v of t because that's what it's called. V of t is continuous. Slade, what else do I need? So by using IVT, cool. We stated IVT. Luke, what else did you have? No, you're good. I'm gonna write it on the interval from what is it, 0 to 60? We stated the interval on 0 to 60. What else do I need here? Aaron, what else do I need? Good. V of 0 is equal to -20. Cool. She's just going to go on 0 to 60. So by using IVT on the interval from 0 to 60, V of 0 equals -20 is less than, -5 is less than V of 60, which is equal to 10. Boom. We did everything we needed there. Aaron finished this up there by saying two things. Aaron said what the y values were that we were trying to get, and that -5 falls in between them. So we have stated everything we needed there. Is that a nice, clean sentence? Nope, don't care. Okay, we are not looking for cleanliness. We are looking for making sure we have everything. Okay, this is worth 2 points. You got 2 points if you stated yes, that it's on that interval. Notice here that they went -35 or v of 35 and v of 50. We use 0 and 60 perfectly good. And yes, we had to do IVT. Okay, this is in a little bit older test. So if you notice here, they're missing something. They stated the endpoints and that we were between IVT, guaranteed on that interval. What thing did they not say? And they shouldn't get points there. Okay, I don't know why that this is the true answer because it's not. They need to have continuous. I pulled that from AP College Board. They do not have enough information there. Okay, let's try one more here together. Number 3, the function f is defined by that equation right there. So this would have been like the initial prompt. This is what they would have told you up above. You would have done part A, you would have done part B, and then we would get down here to part C. This is from the 2012 test. Okay, get down here to part C. Now it says, all right, cool. Up above, that was f. But now we've got g. G is defined by this piecewise function, where we're going to do f of x between -5 and -3, and x plus 7 from -3 to 5. Am I continuous at -3? Use the definition of continuity to explain your answer. Go. We are trying to decide if I'm continuous at -3. And we're doing G here, so I set this thing up and I used the wrong letter here. But we're trying to decide, is G of X continuous on that interval? So if I'm continuous at -3, three things need to be true to be continuous: the left, the middle, and the right. And so I already set that up here first. That way I cannot screw this up. I'm going to get full credit if I show that the limit as x approaches -3 from the left of g of x is equal to the limit as we approach it from the right of g of x is equal to g of -3. Okay. Again, by putting that all out there at the beginning, it's just going to save me later on to make sure I've covered everything I need. Okay. Abby, which equation am I using here to find -3 from the left? -3 from the left. So I need to be less than -3. So I'm using the f of x equation. So that becomes this guy right here. It's a little bit weird in there, but we got that one. So the square root of 25 minus x squared. That's the equation I'm using there. I'm plugging -3 in. So it's the square root of 25 minus -3 squared. -3 squared would get me 9. 25 minus 9 would get me 16. Square root of 16 gets me 4. Okay. Then I'm going to find limit as -3 from the right. So then obviously I'm using this equation because that's from the right because it's a number a little bit bigger than -3. All right, cool. So then I'm doing -3 plus 7. That gets me 4. If I'm doing g of -3, which equation am I plugging into? The top one again. So I'm just going to plug into this 25 minus x squared. You don't need to write it out again. I always do just because. But I get 4. 4 is equal to 4 is equal to 4. Is this thing continuous? Yes, there's no doubt. I always like to just cover myself here and make sure I'm good. Yes, G is continuous at x is equal to -3 because the limit as x approaches -3 of g of x is equal to g of -3 is equal to 4. I didn't have to say the left and the right because I already showed that over there before, but I needed that left and the right as well. If you'd like to, you could write that whole thing out and say the -3 from the left, -3 from the right is equal to 4. Questions on that one? Let's just look at the grading so you see how they graded this. 2 points. You got a point if you considered a one-sided limit. So if you found the limit as x approached -3 from the left and the limit as x approaches -3 from the right, you scored 1 point. You got your second point for your answer with justification. Okay, this was their answer. That right there, the limit as x approaches -3 is equal to that. Therefore, I'm continuous. Okay, but you had to show the one-sided limit or otherwise you would get 0 points. Questions on something we did today? Every